Hi students, in this video we see about Cauchy integral formula. Let f be analytic everywhere within and on a simple closed contour C taken in the positive sense. Means f is analytic, f has a derivative everywhere within on a simple closed contour C. This is called closed contour C. It is in the positive direction. So f has a derivative, it exists in the simple closed contour C and it is taken in the anti-clockwise direction. And if z0 is any point interior to C, so if you are considering one point z0, it is an interior point to this closed contour C, then f of z0 equal to 1 by 2 pi I integral over C f of z dz divided by z minus z0. That one represents the Cauchy integral formula. Or else we can also say that if a function f is analytic within, inside and on a simple closed contour C, then the value of the function interior to this C, interior to this contour, are completely determined by the value of the function f on C. So the function value interior to C is determined by the function value f on C. So that is Cauchy integral formula. Now let us see the proof. Since f is continuous, it is derivative. F is analytic means f is having the differentiability implies continuity. So f is analytic, so that means it implies that f is continuous at this z0. Continuous in sense we can find the distance between any two points, and the distance between any two points, small points, the distance closely lie inside this contour. So that is continuous. Since f is continuous at z0, there corresponds to any positive number. Now we are considering some positive number. It is like mere small number. It's an epsilon and a positive number delta, such that you are considering the distance between f of z and f of z0. Z is any interior point. Some point lies in this contour. So z minus z0 is less than epsilon. Strictly modulus of f of z minus f of z0 is strictly less than the positive number epsilon whenever the distance between z minus z0 is less than delta. This is the basic definition of continuity. Let us choose again one positive number, rho. That rho length is less than the delta, less than delta instance, another one positive number. So that it is a positively oriented circle. So the distance between z and z0 is strictly that we are considering the distance to be positive, equal to rho, and it is denoted by C1, interior to C. So inside contour we are considering. Then the image modulus of f of z minus f of z0 is less than epsilon whenever modulus of z minus z0 is less than rho. There between C1 and C we are finding the continuity. So f of z minus f of z0 strictly less than epsilon whenever z minus z0 is less than rho. Now that you naming it as some star. So you will use this step in the later on step. Now since the function f of z divided by z minus z0 is analytic in the closed region. Analytic means the derivative exists in this closed region consisting of the contours C and C1 and all the points between them. Between these two contours, so we are considering the points in the way integral over C f of z dz equal to integral over C1 f of z z minus z0 into dz. Now multiplying both sides by 1 by 2 pi I. So 1 by 2 pi I, if you multiply, you will get 1 by 2 pi I integral over f of z z minus z0 dz equal to 1 by 2 pi I integral over C1 f of z z minus z0 into dz. Now after this all falls a derivation. Now adding and subtracting f of z0 on the RHS, this side RHS. So f of z0 we are adding. So into 1 by 2 pi integral C f of z z minus divided by z minus z0 dz equal to 1 by 2 pi integral over C1 contour. C and C represents a contour and contour 1. So f of z minus f of z0 plus f of z0 divided by z minus z0 into dz. Now we are splitting this integral. So this is first integral and plus f of z0 by z minus z0. This is second integral, that you naming it as 1. Now we are considering the second integral. In that z minus z0 we are already taken to be modulus of z minus z0 equal to rho. So rho. So theta is the value lies between 0 and 2 pi. That is, it's a closed contour. So it is a 360, lies between 0 and 360. So z minus z0 equal to rho into, so we are multiplying by e power I theta. that explanation is the below. So z equal to we are considering to be a plus r e per I theta, where in place of a we are considering, that is interior center point, we are considering to be the z naught, and in place of r radius we are considering to be the rho e per I theta. Since it is a circle, we are considering as a plus r e per I theta, so rho e per I theta. So differentiate on both sides, we get dz equal to z naught becomes 0, so rho into I into e per I theta differentiation is I into e per I theta into d theta. Now 1 by 2 pi I integral over c1 f of z naught z minus z naught dz is written as 1 by 2 pi integral over 0 to 2 pi. The limits is getting changed between the theta value. So 0 to 2 pi f of z naught, z minus z naught we are considering to be as rho into e per I theta into dz we are considering as rho into I e per I theta d theta. Now all this gets cancelled. Rho e per I theta will get cancelled from the numerator and the denominator. So the left out term is, and I is also getting cancelled. So left out term is 1 by 2 pi integral 0 to 2 pi f of z naught into d theta. So f of z naught by 2 pi you remove out. So what is left out is integral 0 to 2 pi d theta. So integration of d theta is theta, and substituting the upper and lower limits, we are getting 2 pi minus 0. So we are getting 2 pi. So 2 pi will get cancelled. So f of z naught. So that is equal to 2. Now we are considering the first part. So the part, this one, we are considering the first beginning part, this one. 1 by 2 pi integral over c1 f of z minus f of z naught by z minus z naught into dz. So you are taking modulus. When you take modulus, you are splitting up the modulus. The modulus of z1 plus z2 can be written as less than or equal to modulus of z1 plus modulus of z2. So we are applying the same concept here. So modulus you apply on the left hand side, that is strictly, that is less than or equal to, it's not strictly, it is less than or equal to 1 by modulus of 2 pi I integral over c1 modulus of f of z minus f of z naught by z minus z naught modulus of dz. So now I have given the explanation. Integral over a to b w of t dt into modulus can be written as integral over a to b modulus of w of t into dt. So that is what I did here. The same property I applied here. So less than or equal to 1 by 2 pi integral over c1. This modulus of f of z minus f of z naught, already we have named it as star, which is nothing but epsilon, and modulus of z minus z naught is already we have given it to be rho, and modulus of dz. So this is by star. So the explanation is given. So this is by star. So 1 by 2 pi epsilon by rho, so 2 pi by rho. So that is the circumference of the circle. So it is 2 pi rho. So therefore 1 by 2 pi integral over c1 f of z minus f of z naught by z minus z naught dz is written as less than or equal to epsilon. So we are getting the value to be epsilon. So we are written as epsilon. Since epsilon is an arbitrary, it tends to 0. So the value of epsilon becomes 0. So you can remove the modulus. So 1 by 2 pi integral c1 f of z by z minus z naught dz equal to 0. Now apply this, whatever the value we got, now we are going to apply this in 1. So integral over 1 by 2 pi integral over c f of z by z minus z naught dz is splitted as 1 by 2 pi integral over c1 f of z by f of z naught divided by z minus z naught into dz plus 1 by 2 pi integral c1 f of z naught by z minus z naught to dz. So already we got this to be 0, that is the previous step, plus this is a one which we got from the previous explanation, that is 1 by 2 pi integral over c1 f of z by z minus z naught to dz. So which is nothing but 0 plus f of z naught by equation 2 already we got. So that is equal to f of z naught. Therefore f of z naught equal to 1 by 2 pi I integral of c f of z by z minus z naught dz. This is Cauchy integral theorem.